So today we're going to learn how to graph linear functions. And we're going to start with this example over here, y equals 3x plus 2. So if we're given an example of a linear function like this, and we're told to graph it on an xy plane like this, the first thing we always need to do is we need to debunk what are the actual values important in this linear function. The first one that's important is the gradient. That tells us whether it's going to be a line increasing from the bottom left to the top right, or from the top left to the bottom right. So an example of a line which looks like this would have a gradient which is positive. However, if we have a line that goes from here to here, that would have a gradient which is negative. And because our graph here is positive, we know it's going to go from bottom left to top right. The second thing we can do is we can look at our constant, which is in our linear function. This is our y-intercept. And so right away, I can immediately plot that point down right over here. And I can say this point is 2, 0. Now that I have this, I can sub in any other value into this, and I can see what my graph looks like. And what do I mean by that? So we already know, by the way, these coordinates should be 0, 2. What I mean by this is, now that we have what the y value is when x equals 0, let's find out what the y value is at another x point. And for simplicity's sake, I will substitute 1. So when x equals 1, what is y? Well, when we substitute in 1, we get y equals to 5. So I already know that another coordinate system that I have is 1, 5. So I'm just going to roughly plot that somewhere over here and say that that's 1, 5. Again, my graph is not to scale, but if you have scales on your test paper or on your graphing paper, by all means, please do it to scale. And that's it. Now that I have these 2 points over here, all I can do is I can connect them up with a straight line. And that is how you draw any line on a Cartesian plane. So let's have a look at another example. Y equals minus a third x take 3. Again, I'm going to draw a Cartesian plane, and it won't be to scale, but if you have your own Cartesian plane which has numbers on the axes, by all means do it accurately using those numbers. So again, let's figure out what numbers we can actually plot. The number that I use is the constant, which is minus 3. And therefore, if I were to plot that number on my graph right over here, I would say this number is 0, minus 3, as that is my y-intercept. Then all I need to do is I need to substitute any value other than 0 for x. And just to make it simple, I'll substitute 1 again. So if I substitute 1 into here, I'll have y equals negative a third times 1 take 3. That's the same as y equals minus a third minus 9 over 3, which is equal to 10 over 3, or roughly 3.33, or minus 3.33. So now that I have y equals that, I know that a coordinate that I can draw is 1, minus 10 over 3, which is also the same thing as minus 3.33. So that's it. Let's plot that point as well. That point would be somewhere roughly over here. Again, it's not to scale, so be mindful of that when I'm drawing. So this point here is just 1, 10 minus 10 over 3. And that's it. Now that I have these 2 points over here, I can just connect them up with a straight line that passes through both the points. And there we go. That's how I would draw this line, given the equation. Now what happens if we have an example like this, where it's not in the form y equals mx plus c? It's not in the form of slope-intercept form. It doesn't look like this. Well, my advice to you for now is I would convert this to make it look like a slope gradient, gradient intercept form. And the way I would do that is I would just rearrange this equation for y. So first thing is I would move this 1 to the other side, because the opposite of 1, adding 1, is minusing 1. So I'm going to minus 1 from both sides. Now I have this equation, and I'm interested in just y, not 2y. So what I'm going to do is, because currently I'm multiplying by 2, the opposite of multiplying is timesing. So opposite of multiplying is dividing. So I'm going to divide both sides by 2. And there you go. I have it in my gradient intercept form now. And so now once again, we can repeat the steps. So I'm going to take the constant as the y-intercept, because that's how it is in slope-intercept form, or gradient-intercept form, wherever you're from. And that would be roughly here. This would be the coordinate 0, minus a half. Again, not to scale. Now I need to find one other point. I need to find another point that lies on this graph. And again, for simplicity's sake, I'm going to find the y value when x equals 1. So let's work out what that value is when we substitute x equals 1. 2 minus a half, and 2 minus a half is simply 3 over 2, or also 1.5, whichever one you prefer. So therefore we know another point that lies on this graph is 1, 3 over 2, or 1.5. And that point will lie somewhere over here. 2, 1.5, somewhere over here. Again, not to scale. And there we go. All we have to do now is connect the 2 points, making sure it's roughly between the two. Obviously on paper you won't have the technology features that I have, but use a ruler and you should be pretty easily able to draw this line on a Cartesian plane. And that's how you draw a line that's given to you in gradient intercept form.